Okay, and so we've got the single phase breakers here, so we'll start turning those off. And so you can start seeing some lights go off.
Yeah, I'll just show that because we're working in the world's most terriblest place, aren't we, today? Look at that. Okay, so yeah, whips them off.
So just do the single phase. So the lighting's just gone off in here. Do you want them to stay on just for now?
No, we'll turn everything off. We'll do it properly.
And so then we've got our 3-phase breakers. So that's a blower, a compressor,
okay.
3-phase supply to another board there, to the office board.
We turned off a lot of the local loads as well, so we're not actually got loads of stuff on full load on for the breakers, and then obviously we can do the...
And so that looks like all the loads have been taken off.
Yeah, and we're going to do the main switch, are we now?
Now it's quite happy just to turn the main switch off.
The board's off, the cover's off, and we're now going to carry out the external earth fault looping pin. Just remind me why I'm going to disconnect the earthing conductor, which is here.
Okay, so yeah, so it is the main earthing conductor. So if we was not to disconnect it, then we'd be having a problem with parallel earth paths via sort of like the extraneous conductive parts through the bonding and stuff like that. So we want to know the external earth fault loop impedance, and so by removing this earth, that is just the external, nothing internal.
Okay, and we've got an earthing range, as I said, of TNCS.
Yes. Yeah,
so what's the maximum reading for that for the external?
On a PME or TNCS, it's 0.35 ohms.
Earthing conductor's out. We're just going to drop this off.
Right, so yeah, we've got the earth out.
Still care, because obviously the bottom side of this is live, but we're in the real world here, so they're now live at the bottom of that switch.
Yeah.
And it's red, yellow, blue, and not brown, black, grey. And we're going to set up our instrument now in order to carry out that external earth fault loop impedance. So we've set our Mega MFT 1730 up to LPE, and you're going to do it on the 3-lead low, and that's what you've selected to do it on. We could have done it on high because there's no RCDs, but you think that this will probably be the standard practice to get used to, Matt, is that right, when we've got so many RCDs around that we go for the low setting? Is that okay?
Yes, yeah.
Right, okay, do you want to probe on for me?
Disconnected earth there, so we'll get a nice good connection onto there. And then we've got the neutral terminal here,
yep.
And then we've got our 3 phases there, so let's just move that one out of the way. Again, it's an automatic test, so go onto the neutral terminal first, and then we'll just probe onto the first line conductor, and as you can see there, the machine is automatically detected voltage, and it takes a few seconds
because we're on the low one. Yep, that's fine. So we'll persevere and wait for our result.
So as you can see there,
so that's it, we're finished, pack up and we're ready to go. Is that right, Matt?
No, so that's on one of the phases, so obviously there's 3 phases, so we'll just repeat that same process on the next phase. So again, because we're going between neutral and the phase, it's detecting a single phase voltage, so I think it's about 240 volts in here.
Of the 3 readings we take, which one are we going to record?
So it's just the highest reading.
Okay, so we've got to remember we've got 0.08, now we've got 0.09, so that's now the highest one.
Probe back on. If you notice, every time I physically
take your probes back off in the right order.
Take them
exactly
off,
the same as we do for obviously supply polarity and safe isolation. Yeah, right. 0.08 of an ohm. So we've carried out the external earth fault loop impedance test there. We've got 3 readings. You said you're going to record the highest one in your test paperwork. Yeah. Okay, we'll remove the earthing conductor. Just remind me again why we removed that.
So purely for parallel earth paths, we want the external earth fault loop impedance, and so that is the external earth that goes back to the supply transformer.
Good.
That is the one that has to be removed.